Hi, welcome back to this channel. Basically, we already have the idea about reaction carried out by benzene and also alkylbenzene. So in this video, we're going to complete others tutorial question that we haven't discussed in the last two videos. Let's start. Tutorial question objective. Which of the following compound is aromatic? So for a compound to classify as aromatic compound, it needs to fulfill four requirements. First, it is planar. Second, it is cyclic. Third, obey Harker's rule. And fourth is completely conjugated. Okay, so I think all the options A until D, 1 and 2, planar and cyclic should be no problem. So now we focus on the Harker's rules at where we need to use the formula 4n plus 2 equal to. So question A have 2 equal to pi electron. So A have 2 pi electron, so basically n is equal to 2 minus 2 over 4, so it is not equal to integer. So 4n plus 2 equal to 4, so n will equal to 4 minus 2 divided by 4, which is equal to 0. This one is equal to 2 over 4, which is 1 over 2, so B also not the answer. C, we have 10, so 4n plus 2 equal to 10 electron. N equal to 10 minus 2 divided by 4 equal to 2. So basically from here we will have the idea C supposedly will be the answer. However, we double confirm, we complete all the questions. So 4n plus 2 equal to 8 because of 1, 2, 3, 4 pi bond. So n will equal to 8 minus 2 divided by 4, which is 3 over 2. Okay, so the answer is C. Proceed to tutorial question number 8. The diagram below shows the reaction scheme for benzene and its derivative. So identify the compound X. Compound X is over here, and then the product is benzoic acid. So basically we know that benzoic acid can be produced from the oxidation of alkylbenzene with benzylic hydrogen. Okay, so since here they didn't give us the reagent, so we can consider that it will produce the most simple alkylbenzene, which the compound X can be the methyl benzene. Okay, question B, suggest how X can be prepared from benzene and then write an equation. So if we want to write the equation, maybe we can continue over here. Okay, so the methyl benzene react with, it might be from benzene, it might be from benzene, which going to react with a methyl chloride with the presence of the catalyst AlCl3. One of the hydrogen in the benzene will be replaced by the CH3 because CH3 is the electrophile in the CH3Cl. And then the hydrogen electrophile will combine with the Cl negative to form HCl. So this is the equation at where we need to give the organic compound and also side product. What reagents are required to carry out conversion 1 and 2? So 1 is over here, as we already know this is oxidation. So 1, the reagent will prefer is KMnO4, H plus and heat. Okay, so conversion 2, and we know that this is the difference here. So reagent 2 will be the concentrated nitric acid with the presence of concentrated sulfuric acid, and then the condition is 50 to 55 degrees Celsius. Name the type of reaction in 1. So 1 is oxidation, while 2 is electrophilic aromatic substitution. So the next is name compound Y. So alkylbenzene, which is the methylbenzene, if they undergo chlorine with the presence of UV, means that it's free radical substitution. One of the hydrogen in the methyl will be replaced. So the structure of Y will be like this, replaced by the halogen, so it's CH2Cl. So the name can be known as benzyl chloride. Okay, so the structure X can have more than one answer, methylbenzene. If you are not using methylbenzene as the X, then the structure for the Y definitely are different. So if you have others answer, you can discuss with your friends and me during the tutorial time. Tutorial question number 3. What is the function of the Lewis acid in halogenation of benzene? So generally, we always say that the Lewis acid is the catalyst. But when we refer to the mechanism, for example, in the mechanism of step 1, the lone pair of the chlorine atom will attach to the fluorine because iron, because the iron is incomplete octet. So at this moment, the iron will become charged negative, and chlorine, which sharing the electron, always have positive charge. So in step number 2, the pi bond from the benzene will attack the lone pair of the chlorine here. So and then the bond here will break down, become the heterolytic. So from here we can see the Cl is attached to the benzene ring. So in this case, the chlorine is added as the electrophile. So that's why the answer is B. It produces an electrophile. Okay, let's proceed to question number 10. Methylbenzene is a derivative of benzene that is less toxic. Now you are going to suggest a simple chemical test to differentiate benzene and methylbenzene. So based on these two names, so we know the difference is the methyl part. Okay, so the methyl part basically is similar with the alkane. So we need to recall back what is the reaction that carried out by alkane, which is the free radical substitution. Okay, alkane will react with the halogen. However, we have two common halogen. One is chlorine and one is bromine. Because this is the chemical test, we need to show the observation. So here we will prefer to use bromine. So at where we can call this one as bromine test. And then we have the methylbenzene react with the reagent Br2CH2Cl2 with the presence of UV will become benzyl bromide, and the side product is HBr. So the observation is reddish brown of bromine decolorized. Okay, while the benzene, when react with bromine with the presence of the UV, has no reaction, and the observation is reddish brown of bromine remain unchanged. Proceed to part B of question number 10. We need to highlight the mechanism at where between the benzene with the chlorine using the anhydrous aluminium chloride at room temperature. So step 1, we're going to produce the electrophile. The halogen have 3 lone pair electrons. One of the lone pair electron will given to the aluminium because aluminium in this case is still as incomplete octet. So when the chlorine have 3 lone pair electrons, but then now share 1 pair with the aluminium, so become 2 lone pair electrons, so the charge will become positive. And the aluminium now have extra electron will become charged negative. So now we can proceed to step 2. This intermediate is very unstable. Okay, and then the attack of pi bond on the electrophile. Okay, means that the pi bond here have 2 electrons will give to the Cl. So the Cl will break the bond between here. So it's heterolytic, which will using the full-headed arrow. So when this happens, so the bond will open and give to bonded to the Cl. So in this case, this carbon have 4 bonds, while this carbon only have 3 bonds. Don't forget, here still have 1 more bond is bonded to hydrogen. That's why the carbon at the top here will charge positive. Okay, however, the pi bond here will give the electron to this carbon because here is lack of electron. When it do like this, now the carbon initially have not enough electron, already have enough electron, and make this carbon lack of electron, and then the double bond next to it will share the electron with this carbocation ion and make this one become positively charged. So this double bond is keep on rotating, so that's why we say that it shows the resonance structure. Okay, so if you notice that we use the symbol here, this arrow to represent this is the aluminum ion, which is in the resonance structure. So and then because of this Cl gain the lone 2 electrons, so now altogether the aluminum here have 3 chlorine, here have another one, so will become AlCl4 negative. So step 3, when we look at this aluminum ion, we can just take one of them and then bring to the step 3. Now here there is extra 1 electron. So the AlCl4, which have the lone pair electron, which the chlorine have lone pair electron, will share the electron to this hydrogen, and then the bond here will break heterolytic at where this bond will come back to here, so the double bond is formed back. So and then the bond between Cl and aluminium also will break down, so the AlCl3 will form back because it is the catalyst, so it will form back at the end of the reaction. So the Cl here will combine with this hydrogen to form HCl. So with this, the chlorobenzene is produced by using the chlorine with the presence of AlCl3 as the catalyst, which form back at the end of the reaction, and the side product is HCl. Question number 6. Give a chemical test to differentiate following pair. So this one is cycloalkane. Cyclohexane, the actual name, and then this is the benzene. So basically question number 6 is similar with question number 10a that we discussed just now, only the difference here, this one is alkane. So and then just now what we discussed is alkylbenzene. So no matter it's alkane or alkylbenzene, because they have the part of the alkyl group CnH2n carbon-carbon single bond. So that's why we can use the bromine test to differentiate them. So in this case, if they carry out the bromine test for question 6a, the cyclohexane will show the reaction with the bromine in CH2Cl2 with the presence of UV. So the cyclohexane will become bromocyclohexane and the side product is HBr. Okay, so I didn't repeat again for the naming and the name of the test and also the observation and the reaction for the benzene, okay, because it is similar with question number 10a. So now we proceed to question 10b. So 10b is cyclohexene and this is the benzene. So when we see carbon-carbon double bond, so basically we know that we are going to use the Bayer test. So if we use the Bayer test, the cyclohexene will have the changes and means that it is showing the positive result. So we are going to use a co-alkaline KMnO4 and then we'll produce diol with the presence of NMO2, which is a precipitate. Okay, so the observation is the purple color of KMnO4 decolorized and brown precipitate, which is the MnO2, is formed. So then we are going to write the equation for the benzene. KMnO4 OH negative co, and then we write down no reaction, and then the observation is purple color of KMnO4 remain unchanged. Okay, tutorial question number 6. Comparison between benzene and methylbenzene. Benzene will decolorize bromine in UV? No. Methylbenzene will decolorize bromine in the dark? Also no. So basically this one is the alkene and then this one is for alkane. Burn with a blue flame, yellow flame, this one is depends, basically is referred to combustion, and then the color of the flame will depends on the amount of oxygen gas. Okay, so C does not decolorize hot acidified KMnO4, correct, because benzene cannot undergo oxidation. Methylbenzene decolorize hot acidified KMnO4, correct, because methylbenzene consists of benzylic hydrogen, so benzylic hydrogen so can undergo oxidation. Okay, turn blue litmus paper to red. When we mention about litmus paper, it is related with the acidity or basicity. So far we didn't discuss about acidity and basicity, so answer for donkey is not the correct answer, so the correct answer will be C. Last question that we're going to discuss in this video, objective question 8, why benzene undergoes substitution rather than addition? So as you know, in the benzene there are 3 pi bond and then they are able to form the resonance structure. So at where means it is delocalized pi electron. Because of the pi electron is keep on moving, so will make the benzene has extra stability, and then this will make it prefer to undergo substitution instead of addition. So the answer is donkey. So I think we already finished discuss all the tutorial question in the benzene. So hope you can get a better idea and complete the tutorial question. So see you in next chapter, which is the haloalkane.